Today we're going to talk about simplifying rational expressions. If you think back to whenever you first learned about fractions, at some point you probably talked about how to simplify them or how to reduce them. For example, if you were given the fraction 6/8, you were probably not allowed to leave it as 6 over 8 and just say that was a final answer. You were asked to reduce that down to 3/4. Now, there are different ways that you may have been taught to reduce or simplify fractions at that time, but they all would have effectively been based off the same strategy, which is you are basically breaking down each number into its prime factors and then seeing what can cancel. For example, if we look at this 6/8, the other way we could look at this, or another way we could look at this, is that 6 is the same thing as 2 times 3. And 8 is the same as 2 times 2 times 2. Right, so if you think about 8, it breaks into 2 and 4, and then 4 breaks into 2 and 2, right? Well, we know that a fraction bar is the same thing as division. And we know that anything divided by itself cancels out simply to 1, right? 1 divided by 1 is 1, 3 divided by 3 is 1, 100 divided by 100 is also 1. So when I'm looking at this, I notice that I have a 2 in my numerator and a 2 in my denominator. Well, if I simply cancel those out, all I have left in my numerator is a 3, and all I have left in my denominator is 2 2's. Well, 2 times 2 is 4. That is how we know that 6 over 8, 6/8, simplifies or reduces to 3 over 4, 3/4. This is basically the same concept we want to use for if we want to simplify rational expressions. For example, let's say we have x squared minus 4x minus 5 over x squared minus 2x minus 15. Right now, at this point with what we have in front of us, I have no idea whether that is the simplest form of this rational expression or not. The only way I'm going to know that is if I break both the numerator and denominator down to its factors and then see if their factors can have anything in common that we can cancel out. To be clear, we need to factor them separately, meaning right now you almost want to look at this as if you have two problems that you're doing. We are factoring x squared minus 4x minus 5, and then we also are being asked to factor x squared minus 2x minus 15. So if we look at just the numerator, we would be looking for two numbers that multiply to a -5, but add to a -4. Don't forget there is some review videos on factoring that you can go back and look at if you need to. Two numbers that would multiply to -5 but add to -4 would be -5 and +1, right? -5 times +1 is -5, but -5 plus 1 is -4. So we could change, or we could factor x squared minus 4x minus 5 into x minus 5 and x plus 1. If we look at our denominator, the x squared minus 2x minus 15, well, that one, we'd be looking for two numbers that multiply to -15, but add to -2. In this case, two numbers that multiply to -15 and add to -2 would be a -5 and a +3. -5 times +3 is a -15. -5 plus 3 is -2, meaning we could factor the denominator to x minus 5 and x plus 3. So if we take a look at what we have here now, we notice that there is some things in common between the numerator and the denominator. Mainly, there's an x minus 5 in both the numerator and the denominator. Like we already said, anything divided by itself cancels out to simply 1. So even though I don't know the exact value of x minus 5, since I don't know what x is, I know that x minus 5 divided by x minus 5 is still going to cancel out. That's what allows us to go ahead and reduce this rational expression, to simplify this rational expression. If we cancel out those x minus 5's, all we'd be left with is an x plus 1 in our numerator and an x plus 3 in our denominator. Do recognize that is as far as you can simplify this. You cannot try and cancel out those x's. This x is bound to the 1. It's x plus 1, not x times 1. And this x is bound to the 3. It is x plus 3, not times 3. Addition and subtraction signs are pretty much just binding everything together, and you're not going to be able to do much with that. If you need to put parentheses around it like I just did there to remind yourself of that, by all means keep the parentheses there. Either way, this would be your answer. Let's look at one more example here, because you don't always get one that can simplify. For example, we have x squared minus 2x minus 15 on here. Well, we've already factored that. So if we know, we already know that if we're looking for two numbers that multiply to negative 15, but adding to negative 2, that would be negative 5 and positive 3. Right? So we know that the numerator can factor to x minus 5 and x plus 3. Our denominator is a new polynomial. In this case, we'd be looking for two numbers that multiply to 20 but add to positive 9. Well, two numbers that multiply to 20 but add to 9 would be 5 and 4, meaning we could factor this denominator to an x plus 5 and an x plus 4. You can see that whenever we factor these out, we realize that actually none of these factors match up, right? X minus 5 is not the same thing as x plus 5. So in this case, nothing happens to cancel out. That can happen. It's not a problem. Your answer is either going to be this rational expression with it factored out, or you can just say that the original, the way you had it, was your answer as well, right? Either one of these is really acceptable because we didn't really do anything. It's just two different ways to write it. But I just wanted to point out that sometimes they will not cancel, and that's okay. You're not forcing things to cancel. You're just factoring to see if it can happen. Really, the main thing you need to know for this lesson is the ability to factor polynomials. If you can factor polynomials, the rest is just seeing what may or may not be there for you to cancel.